Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Mukhlis Abd Kadir. My supervisor is Encik Khairul Imran bin Sainan and my co-supervisor is Dr. Muhammad Azimin bin Abdul. Welcome to my presentation. So today, I'm going to present about my FYP, which is visualizations of football kinematics by means of big data analysis. Okay, so first, I will start with the presentation content. In the presentation content, I will start with the introduction and we'll go to the problem statements, objective, and also with the project scopes. Okay, next, I will move with the project methodology, results and discussion, and finally the conclusion and recommendation. Okay, let's start with the introduction. Okay, so why I wanted to do with this football kinematics visualization. Okay, so as we know, football is the most popular sports in the world. The data visualization techniques in football analysis is very important to the end users such as coaches, professional athletes and staff. It's helped them to digest the information very conveniently. In one of the articles that I found, the author mentioned that graphical representations are the most effective way of interpreting results. The graphics may help people to offer insight far easily than words can. In another article that I found, the author mentioned that the data visualization techniques is a technique that successfully conveys sensations through visuals. So, with various developments in science and technologies, any data related to sport analysis can be illustrated more conveniently than ever. Therefore, it will enhance and intensify football performance analysis as graphics and visuals provide more effectiveness for the end users to digest the information. Problem statements. What problems that inspired me to do this kind of project? So I have two problem statements that inspired me to do this project. Okay, so first, the unstructured big data. The unstructured big data is very complex and requires too much of data to do with them, and which needs visualization techniques to analyze the football kinematics at various levels. Second is the approach to visualize the data. The wrong approach in visualizing the football kinematics data may result the data obscured. Next is the objective of the project. In this project, I have two objectives, which is the first one is to represent the kinematics data visualization techniques in terms of colors intensity. Second is to improve graphics, visualizations, and presentation. Okay, let's move with the project scope. Okay, the first scope, the visualization development using a script language and its library modules. Okay, the second one is big and high dimensional data framework to visualize the football kinematics data. And the last one is the interactive visualization of graphics and visuals. Okay, now let's start with the methodology of the project. Okay, in this methodology, I will explain about three things. The first thing is the heat map. Second is the stacked bar charts and line graph. The third one is the scatter plot matrices moving dot graph. Okay, let's start with the heat map first. Okay, for the heat map, it was designed in the notebook using a script language, which is the input is a set of data frames that we record from an actual matches between SSAFC and Monster FC in a social league in Shah Alam. And the output of the heat map is a football heat map. Okay, so as we can see, there are the process of the heat map visualizations, which is the first one, we impute modules. Second, develop data framework. Third, visualization process. The fourth, using data viz and UI tools. And lastly, it will display a heat maps. Okay, for the data framework, as I mentioned before, it was recorded from an actual match between SSAFC and Monster FC in a social league in Shah Alam. Okay, the data set contained numerous kinematics data. However, the initial data was in X and Y location. Okay, so the process of the data framework start with we import data analysis library into the notebook from the script language database. Then we call the data frame using the library function, and then we call out the data, which is speed, acceleration, and the distance covered. Okay, after that, the speed, acceleration, and distance covered will be displayed in another function, or if not, it will be stored in the local storage. Okay, so the input for the data framework is the numerous kinematics of data from electrical measures, and the output for the data framework is the speed, the acceleration, and the distance covered for all the players of the whole matches. Okay, so next is the visualization process. Okay, the visualization process consists of two, which is the first is the pitch orientation. The second one is the visualization techniques. Okay, let's go with the first one, which is the pitch orientation. Okay, the pitch was set by a custom pitch class and was imported from the football plotting library, and the football plotting library also was imported from the script language module. Okay, next, the standard pitch length and width for the field was set as 85 and 70 meters, and the requirements was referred at the FIFA, which is the Football International Association. Okay, next, the pitch color was set to grass and the pitch line was set to white. Okay, enable to give the field more attractive for the visualization. The stripes for the pitch was set to true. The second part of the visualization process is the data visualization techniques. It starts with we import the data visualization library from the script language database. Then from the framework local storage, we call the data framework to create the data frame location argument for the x and y axis. Okay, so next, the color intensity of the kinematics data frame structures was shown using a kernel density estimation, which is KDE. We call the visualization function for the KDE to create the shade argument. The shade argument is the alpha values and the n values to give the heat map more intensified in terms of its colors. Okay, then we call the color map function to create the color map style. Then we will display the heat map for the football. Okay, after we have success to display the football heat map in the notebook, we use an extension processing array to display the football in a data viz and UI tools before it was transferred to a web application. Okay, so a multi-dimensional array and matrix data structures and height level API were added as extension files in the desktop application. Okay, the libraries were fetched using the pip instruction. The modules generate a multi-dimensional array object from the script language file, and the complete football map was shown in the application of the tools before it was embedded into the web application. Okay, so for the flowchart of this process, we installed an extension arrays file in the web application from the notebook in order to link the notebook with the data viz and UI tools. After that, all the codes were transferred into the data viz and UI tools before it was embedded to the web application. Okay, for the next methodology is for the stacked bar charts and the line graph. Okay, for this stacked bar charts and line graph, it was designed using a desktop application. The input of the process is a set of kinematics data frame, which is the calculated ones, the speed, the acceleration, and the distance covered. The output of the process is to display the distance covered bar charts, speed, and acceleration in line graph. Okay. For the process of the stacked bar charts and line graph, first we set the width and height. Second, we set the legends. Next, we set the font family and its size. Next, we set the texture alignment. We set the scale types, and lastly, we set the background color. For the stacked bar charts and line graph, it's quite simple for the process. Okay, now the last part of the methodology is the scatterplot matrices moving dot graph. The graph was designed using the desktop application. The input of the process is a set of XY coordinates, and the output is a scatterplot matrices moving dot graph. Okay, the process of the scatterplot is first we set the X and Y axis by using the XY coordinates. Second, we set the data color to difference the two teams. for SSAFC and the other one is for the Monster FC. Next, we set the marker shape, also same, to differentiate different teams. And last one is we set the background image for the player. For this background image, we set the pitch that we have created just now. Okay. So now for the results and discussion. Okay, this part also consists of 3 parts, which is the first part for the player attribute visual analysis. The second part is the player performance indicator, and the last part is the match statistic visualization concept. Okay, first we go to the player attribute visual analysis. Okay, for this results, we show a heat map for the both team during the whole match, which is between the SSAFC and the Monster FC. As we show in the slide, in the picture, there are the heat map for the teams. The blue one is for the SSAFC. The purple is for the Monster FC. The colors of the heat maps was created based on the major color of the team. As for the SSA, their team's color is blue, and for the Monster FC, their team's color is purple. Okay, the heat map was developed in a notebook using a script language. The heat maps also reflects the region in which a player was represented throughout the whole match. A unique color scale was utilized to address data collection for the end users. For this heat map, 20 different color tones has been used to create the heat maps, able to attract to the end user. Okay, for the next result is the player performance indicator. Okay, for this one, we will first analyze the distance covered for every player between the SSAFC and the Monster FC. The stacked bar charts was developed in the desktop application, and it can be filtered by teams, players, and positions. Besides that, the stacked bar charts also can be shown in a real stacked bar chart, which is the bar charts can be shown from time to time by click the play button, as we can see below the stacked bar charts. Okay, for the stacked bar charts also we use the same rule we use for the blue color for the SSAFC and the purple color for the Monster FC. As we can show, the stacked bar chart showed the distance covered for every player with their names and their jersey number at the stacked bar charts. Okay, for the next player performance indicator, we analyze the speed and acceleration using a line graph. The line graph trying the motion analysis distribution for every player during the match in terms of speed and their acceleration. The graph also can highlight individual data points, data series, and range for every minute of the players during the whole match. As we can see, the blue line graph is for the SSAFC, and the purple is for the Monster FC. So this line graph was improved, and it's different from the other line graph. Last result for the player performance indicator is using the scatterplot matrices moving dot graph. It displays object tracking, visualization, and attribute positioning on the field. The scatterplot also can be filtered by teams, players, and positions. Besides, it can provide a real-time moving dot graph. Okay, it is very important for this scatterplot because if we play the play button, the player's position will be moved according to their actual position during the whole match. Okay, the last result for this project is the match statistic visualization concept. Okay, the concept was designed using a web application, and several computer code elements were implemented during the concept design. Okay, for the concept design, we include all the findings that we have created into the web app, and as we can see in the slide, the design concept, we put all the match information such as the team's logos, the list of the players, the heat map, the stacked bar charts, and the line graphs. Okay, so To ease the integration of the data for the end users, all the users can access this design in their web app in any of their devices at anywhere at they want, as long as they have their internet connection. So this is the final design that we have created. Okay, for the conclusion and recommendation. Okay, first, the study reveals that the football map significantly influences the end user's ability to retrieve the data. Okay, next, the proper types of graphics and visuals will pique the consumer's interest for them to comprehend the information. And the last one, the encouragement of interactive visualizations are required for the big data analysis, as if not, it will obscure the data and the end users will hard to digest the information. Yeah, that's all for my FYP presentation. For any inquiries, you can contact me at the emails or my phone number. Thank you for your listening. Have a nice day. Thank you.